In question number 11, a uniform ring of mass m and radius r is rotated about its axis with constant angular speed omega. If cross-sectional area of wire is A and its Young's modulus is phi, the change in radius of the ring is. First, we need to find the tension that will be developing in the ring. So for that, this being the small angle delta theta, here also delta theta, t along the direction tension t. So I would say the total length of this portion would be 2r into delta theta. And the mass of this much of the part of the system, it will be dm, it will be lambda into 2r delta theta. So if this is t, so net force towards the center, it would be t into 2 delta theta must be equal to delta m omega square r. It is lambda 2r delta theta into omega square into r. Cancelling these two portions, we are getting t to be equal to lambda omega square r square. Fine. Now we need to find the change in radius of the ring. That means if t being the tension t, area is A. Here delta L divided by L. L is how much? 2 pi r. Young's modulus y must be equal to 2 pi delta r. This one will cancel out and we are having change in radius as t divided by ay here into r. T being lambda, it is omega square r square. Lambda was m divided by 2 pi r, that is t. Here it is a y and this is r. This one will cancel out and we are getting the value of delta r to be equal to m omega square r square divided by 2 pi a into y. Looking into the options, we are getting option 2 as the correct answer for question number 11. Now let's proceed to question number 12. In question number 12, 1 mole of an ideal diatomic gas undergoes through a cyclic process ABCA as shown in figure. The net amount of heat supplied to the gas is. Well, looking into the diagram here, it is very much clear that the process from A to B, it is isobaric. Process from B to C, it is isothermal. And from C to A, it is isochoric. So I will just write down how much the energy that must have been given to the system in every different processes. The first one, it is delta Q1 here, that's been given to the system. In isobaric condition, it must be N, number of moles being how much? 1, Cp into dt. From here to here, the change in temperature is 2T naught. This much of the amount of heat has been given. In the next process, B to C, it is delta Q2. It actually has been taken out from here. It is nRT ln V2 by V1. Well, from here to here, it is V0 here and it is 3 V0 here. So yet again, it is coming down to V0. So I would write down here, N is 1, R T0, it is 3 R T0 ln 3. This much of the amount of heat has been taken away from here. Now yet again delta Q3 for the process C to A. It is isochoric process. So yet again the heat has been taken out from here. It is N Cv into dt, it is 2T naught. So this is plus, minus and minus. So what we are getting here, delta Q net, it is 2T naught, Cp minus Cv, it is R minus 3RT naught ln 3 or RT naught 2 minus 3 ln 3. So looking into the option, we are getting option 4 as the correct answer for question number 12. Now let's proceed to question number 13. Here in question number 13, a wire of mass m, length L, cross-sectional area A and Young's modulus Y is suspended. A block of mass 2m is attached at the lower end. The elongation produced in the wire is. We need to find the stress at a particular point x from the lower end. This mass being how much? 2m. So total level of the stress here, it will be 2m plus m divided by L into x into g divided by a. This is the stress at this point. So the total extension at this point, it would have been given by delta L. It would be equal to stress divided by Young's modulus. So it is M2L plus X into G divided by A into L into Young's modulus here into dx here. This will be the total extension of this much of the portion. So integral of this part will give us the total extension of complete rod here. So integrating this part, we'll be getting this value as M divided by ALY, this one 2L x plus x squared divided by 2 from 0 to L, and it is into G. So evaluating this part, we are getting this answer to be equal to total extension is 5 capital MG L here divided by 2y into A. So for question number 13, we are getting option 2 as the correct answer. Now let's proceed to question number 14. In question number 14, a driver of a car traveling with speed 30 meters per second towards a hill sounds a horn of frequency 600 Hz. If the velocity of sound in air is 330 meters per second, the frequency of reflected sound as heard by the driver is. Let's consider this part being the hill here. The first, it is making a sound of frequency that's been given to be how much? It is 600 Hz. So for the first time, when the sound will be reflecting from here, its frequency becomes F1. So I would say F1 to be equal to, it is V, that is V here, divided by V minus the speed being 30. So it is 300 into F0. Now yet again, after reflection, once this driver will be hearing the sound once again, it will have the frequency F2, and this time it is V plus 30 divided by V into F1, or I would say this is 360 divided by V, and the value of F1 was V divided by 300 into F0. So the value of F2, it is coming out to be 360 divided by 300, and F0 was 600. So this is 2 or 720 Hz. This is the frequency the driver will hear. So answer is option number 3. So now let's proceed to question number 15. In question number 15, the time period of vertical oscillations of the system is pulley and the strings are ideal. Well, let's elaborate it a bit. Let this being the one spring here, and it is attached with the string like this way, and this one being other one, and this is mass m. From equilibrium position, let's say it's been shifted by a distance x, and in that case, this spring is actually extended by x2 and this one extended by x1. So I would say the tension here in this spring, it will be kx1, fine, along this direction, and it must be equal to the tension of this spring. So this t, it will be 2, must be equal to, it is 2k into x2. Got it? So we are getting extension in spring 1 and the spring 2, these two are same. Now, the restoring force that this mass will experience, it is F restoring, I would say it is 2k into x2, and its displacement from the mean position, that is x, I wrote it, x will be equal to, if this part has been extended by a length of x1, so this part shall have the contribution of x1 by 2, and it is having the extension of x2, so it will be x2 here. So x actually, it is x1 is actually x2, so I would say it is 3 by 2 x2, or it is 2x divided by 3 is equal to x2. So replacing this value here, we are getting 2k, x2 being 2x divided by 3, or F restoring effectively, it is 4kx divided by 3. Fine. Now, this is the restoring force. So once the mass will execute the simple harmonic motion, the value of omega square, that is to be taken as it is 4k by 3m, and the time period t will be 2 pi divided by 3m 4k. So looking into the option, effectively we are getting option 4 as the correct answer here. This 4 will come out from here and it will cancel out with 2. So option 4 is the correct answer. Got it? Now let's proceed to question number 16.